Hello everyone, my name is Shazibul Huda and it is my fifth and final demo video. In this video, we are going to learn about microservice architecture. In the last video, we have discussed a little about it. In this video, we are going to learn about its attribute with the help of presentation to make it more virtually appealing. So let's start with this video. So first, what is microservice? Let's start with the basics. First, when we talk about software architecture, there are generally two main types that stand out, which are monolith architecture and microservice architecture. Monolith architecture is an old architecture which was used before microservice architecture. This is a traditional model where all components of an application are tightly connected and function as a single unit. It's like building one large block where everything is interconnected. So a change is one part of the application and affects the entire system. As for in microservice architecture, in contrast, microservice break down the application into a collection of smaller and independent services. Thinking of it like a team where each person has a specific role. Each service is like a mini application responsible for one aspect of a larger system, operating independently and communicating with other through APIs. So why is this approach valuable? Microservice brings flexibility and scalability to the table, since each service is separate, so you can update, scale, or replace one service without disrupting the entire system. This is essential for modern applications that needs to adapt quickly to change in the demand or technology. Microservice in modern applications. Digital products today, especially those in cloud environment, flexibility is the key. Microservices allow for faster and more manageable updates. Instead of updating one large block, developers can focus on improving one part at a time. This means fewer delays and ultimately a better experience for the user. In real world, microservices can be used such as now to make this more tangible. Let's look at at some tech giants who leverage microservices. Some of the famous companies like Amazon, Netflix, and Uber use microservices in their different ways. Netflix uses Netflix uses microservices to deliver millions of content streams daily. This setup allows to rapidly update its recommendation engine without affecting video delivery or user account management. As for Amazon, splits its e-commerce function into service-like products, recommendation, search, and payment processing. Each can be independently improved and scaled based on the user traffic. Uber's architecture supports high volumes of ride requests while dynamically scaling services like location tracking, payments, and customer support. Each of these companies constant demand fluctuations. Microservice enables them to adapt and scale according to these challenges without the downtime that monolith architecture would likely require. Now, let's talk about the nine attributes of microservices. First is componentization via services. So first of all, we need to ask what is componentization via services? In microservices, componentization means breaking down an application into small independent pieces or services. Each service functions as a self-contained unit and has a single responsibility. Think of it is like a jigsaw puzzle. Each piece fits into a larger picture, but has its unique shape and function. This componentization makes system modular and each services can be developed and maintained separately by different teams without dependencies or other parts of the system. Let's give an example for componentization via services. First, let's consider a retail application as an example. In monolith setups, you might have a single application handling user authentication and product listing, orders and payments. But in microservices models, each of these would be its own service. Such as first product catalog, a service that manages all product information. Second, the order management manages order, tracking, inventory, and shipments. User authentication handles login, registration, and user data security. As for payment processing, manage payment methods, transaction, and refund. Each of the services is built, run, and deployed independently. Each has its own code base, process, and ports, allowing it to easily update it and scale as needed. Let's talk about benefits of componentization. First is independent scaling. If a sale or a promotion spikes traffic to the payment services, you can scale just that service without affecting others, saving resources. Decouple development and deployment. Each team can develop, test, and deploy its services independently. For example, if a catalog team wants to add a new feature, they can do so without waiting on changes from the payment team. Resilience and fault isolation. If one services like order management faces an issue, the other services continue to operate. User might not be able to place an order temporarily, but they could still browse the catalog or update their account information. Ultimately, componentization in microservices provides agility in responding to user needs and managing updates without the ripple effect across the entire system. In its having multiple lifeboats instead of one large ship, you can update or repair each lifeboat without disrupting entire fleet. Now let's talk about the second attribute, which is organized around business capabilities. First, talk about what is business-centric organization. One of the core principles of microservices architecture is organizing services around business capabilities rather than technical functions. Let's first talk about business capabilities as structural guide. In microservices framework, each service is designed to address specific needs or capability. You think of it as aligning technology directly with the business goals. This approach keeps the system manageable, relevant, and responsive to the business requirement. How microservices are structured. Unlike monolith system, this group that might group code based on a technical layer, like data access or UI. Microservices are designed so that each service supports a key business function. For instance, in an e-commerce application, you can individual service for the product listing, orders, payment processing, and each representing a distinct business capability. There's one important important point in organized in microservices, which is fine-grained services. Let's talk about what it is and under which it comes under which function. Granularity and service size. A critical business needs to struck when deciding the size of each service. Fine-grained service. It's tempting to break everything down into a tiny service, but over fragmentation can lead to too many moving parts, making the system complex and hard to manage. For example, splitting a payment service into a hundred of small tasks might create more overhead than value. Practical service size. The aim is to ensure each service is small enough to focus on single business capability, but large enough to be manageable. A payment service might have a separate component for handling validation, processing, and third-party integration, each addressing an essential business tasks without necessary fragmentation. Detailed example in payment system. To illustrate, wait a second. To illustrate this principle, let's break down a payment service. First, validation service, a component that verifies payment processing, checking things like card validity, available balance, and user authentication. Second is processing service, responsible for executing transaction, debiting the user account, and crediting the business. Third-party integration. For the payment to an external provider like PayPal, this component ensures smooth integration and handles API calls, manage specific provider-specific requirements. Why is segmentation effective? Dividing the payment process in this way allows each service to specialize and optimize for its task. It also keeps each service independently scalable and upgradable. So there is a spike in PayPal payments, for example, only third-party service needs scaling. Some of the benefits of business-centric organization is it is maintainable and aligned with business needs, and it is also adaptable. Now let's talk about its third attribute, which is decentralized governance. Decentralized governance is a key principle in microservices that enables each team to make its own technology choices rather than following a central enforced tech stack, as you find in monolith systems. So let's talk about what is the difference between versus decentralized control. In monolith setup, there is usually single tech stack chosen for the entire application. This can restrict innovation and agility. Decentralized governance, on the other hand, gives teams the freedom to experiment and pick tools best suit for their specific services. Impact on microservices. Each microservice can be customized with technologies and tools that best fit its purpose. This fosters innovation and allows services to evolve independently. Example of tool diversity. To make the concept more concrete, let's look at some real world scenarios. Such as first we should talk about the programming language which is mainly used to build the application. Imagine a recommendation engine for a retail app which is made in Node.js might be ideal for its real-time capability, while the machine learning-driven analytics service might use Python due to rich machine learning libraries. As for databases for services that requires structured data with relationships like user account service, a MySQL database might be best. On the other hand, a logging services handling large semi-structured log entries may use MongoDB or another NoSQL database for its flexibility and scalability. Third is DevOps tools. Some services might use GitLab for version controls and CI/CD, while others use Jenkins depending on team familiarity and service needed. Challenges and best practices. While decentralized governance has many benefits, it also comes with challenges such as interoperability, while such as interoperability, which vary tools and technology ensuring seamless communication between services can be tricky. Team needs to establish clear API standards and protocols. Managing complexity with many different technologies in play. Documentation and monitoring becomes essential. Using tools like centralized logging and observability frameworks can help manage the diversity. Third is security and compliance. Maintaining a secure system requires teams to follow organization-wide guidelines or data security, even if they use different tools. Ultimately, decentralized governance, when managed well, allows each microservice team to innovate and optimize independently, making overall system more flexible and responsive. Now let's talk about its fourth attribute, which is decentralized data management. Why data decentralized matters. In microservices architecture, decentralized data management is crucial because it allows each service to independently manage its data without relying on central database. Importance of service-specific databases. In microservice setups, each service has its own database, ensuring independence and reducing cross-service dependency. By managing data locally, each service can optimize storage and performance for its specific needs. As for second, contrast with monolith system. In monolithic architecture, all services typically share a single database which can lead to bottleneck and data conflicts. For instance, in central database becomes overload. If central database becomes overloaded or needs an update, the entire application can be slowed down to go offline. Microservices avoids this issue by ensuring that each service controls and only only access its own data. Rules for data management in microservices. Decentralized data management in microservices follows a few important guidelines, such as exclusive ownership. Each service exclusively owns and directly manages its database. No other services could access it directly. This includes this exclusivity reduces dependencies and promote data integrity. Inter-service data request. If one service needs data from another, it requests the information via an API rather than accessing the database directly. This approach enforces loose coupling between services, allowing them to operate independently and changes without affecting each other's internal structure. As for talking about its scalability and maintenance benefit, first is enhanced scalability. Each services can be scaled independently based on demands. For instance, if there is a high volume of requests for billing data, you can scale the billing service without having to adjust affect the account service. As simplified maintenance and optimization. Each team can optimize their database structure and storage according to the service's unique need. So if the billing services required faster read operation, it can implement an optimized database solution without impacting the rest of the system. Let's say a billing service needs customer data such as contact information which is managed by account service. Instead of accessing the account service database directly, billing services make an API request. The account service responds with the requested customer data, maintaining control over its own database. This API-based approach keeps service independent, scalable, and secure, while ensuring data flows smoothly across the system without direct database access. Now let's talk about infrastructure automation attribute. Role of automation in microservice services. As microservices increase in number and complexity, automation becomes essential for managing the system efficiently. Manual deployment and management of each services are time consuming and prone to human error. So we do the things to reduce complexity, such as automation to reduce complexity. Automating tasks like deployment testing logging reduces the operational burden on the team. It ensures that each microservice can be deployed, monitored, and managed consistently without manual intervention. Scalability through automation. Automation allows for the rapid deployment and scaling for services which is essential for microservices. It enables team to handle changes across multiple services with fewer resources and less room for errors. Automating the build and deployment pipeline. Automation is particularly valuable in the deployment pipeline. Let's look at the stages and how each can be automated. There are multiple stages such as code, build, test, and deploy. In code, developers commit changes to a repository, as in build. The code is compiled and packaged automatically. In test, automated test ensures the new code doesn't introduce issues and deploy the services in deployment to test the product environment. advanced automation techniques. Finally, as the system scales, advanced automation techniques like infrastructure as code (IAC) becomes valuable. IAC tools like Terraform, and AWS CloudFormation allows you to define and manage infrastructure through codes. This means that not only the application but also the servers, load balancer, and databases all configured and deployed automatically. Wait a second. Now let's talk about its sixth attribute, which is product and not projects. Let's start with the concept of products and not project. Traditionally, organizations have approached work as these discrete projects with a detailed start and end. However, this mindset can lead to lack of ongoing support and evolution once a project is completed. Instead, we should think about delivering the product that provide continuous value over time. A product-oriented across approach emphasizes long-term relationships with users where their feedback is integrated into regular updates and improvement. For example, consider a web application like social media platform. It requires constant updates to stay relevant and engage on its user. By adopting a product mindset, we can foster innovation and create solutions that truly meet the needs of the users. Let's talk about its seventh attribute, which is design for failure. We should have an open mindset through multiple stages in design, as there can be success and failure both happen when we do our project. If it's success, let's talk about designing for failures. In software deployment development, it's crucial to anticipate both success and failure. A successful API response indicates that a request has been processed correctly. For instance, when a payment API returns a success response, the system logs this event and notifies the user that their transaction has been completed. This logging is essential for monitoring analytics and as it helps us to understand user interaction and system performance. If it fails, now what happens when things go wrong? A failure response typically indicates that the error has occurred, which can be due to client-side issues, server-side problems, or network errors. For example, if a user tries to retrieve data but receives a 404 error, indicates not found, the system needs to react to the error, providing user feedback and potentially offering options to retry or redirect. Good error handling improves user experience and trust in the system. Timeout presents another challenge. Timeout occurs when we don't receive a response in the expected time frame due to the network issue or unresponsive services. Instead of viewing timeout as outright failure, we should consider them as scenarios requiring intelligent handling. For example, if a request of an external services times out, we should decide to whether retry the request. We can implement a retry strategy, but we must be cautious not to retry endlessly as this could lead to unnecessary load, we might also consider uh, alternative methods to verify the state before retry. Moving to the evolutionary design, it is important to recognize the technology and user needs to change over time. This is where the concept of evolutionary design comes into play. It refers to practice of iteratively improving systems based on the user feedback and changing requirements. Now let's talk about its last attribute, which is smart endpoints and dumb pipes. Finally, let's discuss smart endpoints and dumb pipelines. This concept refers to the architectural distinction of software design where the endpoint, the service, contains the logic, intelligence, where the pipes, the data transport mechanism, focuses solely on the efficient data transfer. Using REST API as an example, we can see the services should handle their own business logic processing while relying on HTTP for communication. This separation allows for better scalability and maintainability, making our system easier to manage by structuring our system this way to ensure the changes in the business logic don't necessitate a complete overhaul of the communication layer. Thank you for watching this video till the end.